Hello, my dear children. How are you all doing? I know, exams are right here, but please don't you worry one bit. I'm here with you. Today, we are going to do a super fast, super easy revision of a chapter that I know can be a little tricky, minerals and energy resources. Chalo, let's get started and make sure you get full marks.
Okay, so let me start by asking you something a little bit strange. What if I told you that this morning, when you woke up, you actually brushed your teeth with rocks? Yes, I am being completely serious. You see, minerals are not just boring things in a textbook. They are in your toothpaste, in your food, in your phone, everywhere.
Just look at your toothpaste. You know that slightly rough thing that cleans your teeth so well? Well, that's silica, limestone, basically ground up rocks. And the fluoride that your dentist keeps talking about, that comes from a mineral called fluorite. Even the pure white color of your paste comes from something called titanium oxide. Oh, and if you use a gel paste with those little sparkles, that's mica. See? You've been a geology expert since this morning.
So here is our mission for today. We'll quickly understand what minerals are, meet their family members, go on a tour of India to find them, see how we get our power, talk about a serious issue, and finally see how you can be the superhero. It's a simple plan.
Okay, first things first. We need to know the proper textbook definition because, exams. But don't worry, we're going to break it down and make it so simple that you will never forget it.
Okay, I know, these words sound very heavy. Homogeneous, definable internal structure, what does it all mean? It's simple beta. Just remember three things. 1, it's natural, not made in a factory. 2, homogeneous just means it's the same all the way through. And 3, definable internal structure is just a fancy way of saying its tiny particles are arranged in a neat, fixed pattern. Like sugar crystals. See how they all have a similar shape? That's it, easy peasy.
Right, now that we know what a mineral is, let's meet the family. Just like in our families, we have brothers, sisters, cousins, minerals also have their own family tree. It might look a little big at first, but trust me, it's super simple.
Whoa, okay. Here's the full family chart. I know, it looks like a lot of names and branches, but don't get scared. Just look at the top 3 main branches. That's all we need to focus on right now. We are going to make this much, much simpler.
And here it is, super simplified. The mineral family has 3 main types. First, we have the metallic minerals. The keyword? Shiny, because they contain metal like iron or gold. Second, non-metallic. Simple, it's the opposite. No metal, no shine like limestone. And third, energy minerals. Well, the name says it all. They are the power givers like coal and petrol. See? So easy to remember.
Now for my favorite part. Let's all go on a virtual Bharat Darshan, a trip across our beautiful country. Why? Because we're going on a treasure hunt to find where all these minerals are hidden. Get your maps ready because this section is full of exam questions.
Our first treasure is the king of all minerals, iron ore. Why is it the king? Because it's the backbone of everything. The desk you're studying on, the fan above you, the bus you go to school in, almost everything is built with iron. It's a total superstar.
Okay, eyes on this map, everyone. This is your treasure map for iron ore. All those little red triangles show where we find it, but we need to focus on the 4 major areas, or as we call them, belts. You absolutely have to know these for your map work. Listen very carefully, my dears. Exam alert. This is a Pukka question. These are the 4 big daddies of iron ore in India. You have the Odisha-Jharkhand belt in the east, the Durg-Buster-Chandropur belt in central India, that really long name, the Bellary-Kitradurga belt in Karnataka, and the Maharashtra-Goa belt in the west. Please learn these names.
Shallow. On to our next treasure. We are now looking for manganese. Now, what does manganese do? Think of it as a vitamin for steel, or maybe steel's best friend. You add a little bit of it and it makes steel super strong and stops it from rusting. Very important.
So, where do we find this best friend of steel? This chart tells us the whole story. Can you see who the champion producer is? Yes, it's Madhya Pradesh, right in the heart of our country, making almost 1/3 of all the manganese. After that, we have Maharashtra and Odisha.
All right, so we found the minerals that build our country. But what powers it? Right now, the light in your room, the phone in your hand, they're all using electricity. But have you ever stopped to think, where does all this power, all this Bijli, come from? Let's find out.
So basically, we have two types of energy sources. Think of it like this. Conventional sources are the old school ones, the ones our grandparents used, like coal and petrol. We've been using them for a long time. And then we have the non-conventional sources. These are the new gen sources, like solar and wind power. They are cleaner, better, and they are the future.
Now this is another very important map for your exam. It shows where we find our main old-school energy resources. Look towards the east of India. All those black dots, that's our coal heartland, places like the Damodar Valley. Now travel west, off the coast of Mumbai. See that big red square in the sea? That's the famous Mumbai High, one of our biggest sources of petroleum.
Okay, bachcho. Now let's just pause for a moment and have a serious talk. A serious baat. We've seen all these amazing minerals and energy sources that help us so much, but getting them out from under the ground, it comes with a price.
Just look at these two pictures. On one side, we see a huge mine, working hard, fueling India's growth. It gives us what we need. But look at the other side. You can see the pollution, the dust, the damage. This is the big question we all have to face. How do we balance our country's needs with the health of our planet and our people?
The truth is, mining is a very tough and dangerous job. The miners who work so hard risk their health every single day. And the process itself can pollute our clean water, our good land, and our precious forests. It is important for us, as responsible citizens, to know this other side of the story as well.
Now please don't feel sad or helpless after hearing all that, because this last section is the most important one. It's about the solution. And you know what the solution is? It's you. You are the future, and you have the real power to make a change.
Just think about this number for a second. 1%. Only 1% of our entire planet's crust has minerals that we can actually use. Just one. It took millions and millions of years for these to form, but we are finishing them so fast, and they're non-renewable. That means when they are gone, they're gone forever.
Beta, if you remember only one thing from this whole chapter, please let it be this golden sentence. Energy saved is energy produced. It's a beautiful idea, isn't it? It means every single time you save even a little bit of energy, you are actually helping to produce it for someone else. Saving is just as important as making.
So I want to end by asking you this simple question. What is one small, tiny power-saving habit you will start from today itself? Maybe just switching off the light when you leave the room, or turning off the tap properly. Every small drop, every small switch makes a huge difference. You are the generation that can heal our world. All the very best for your exams, my dear children. I have full faith in you. You are going to be fantastic. Now go and study well. You will shine.